Today we will be looking at irradiance textures. So irradiance is the process where a material is emitting light. It's kind of like a hack for making things look brighter than they should be in the engine. All of the textures we were looking at previously were rendered incorrectly. There's this concept of sRGB. A regular texture map or a albedo map has got red, green and blue channels associated with it. And sRGB defines like if red is at this value, then it should appear like this bright on the display itself. sRGB was made mostly for CRT displays, so those big, huge, clunky displays, and it would define how many photons, like how much light should come off when a certain color was at a certain value. What we do in the physically based renderer is we don't use sRGB values, we use linear color values. So instead of working with this mapping from sRGB value, like the byte value, to the number of photons, we deal with the photons directly. If you have a value of 0, that means 0 photons. If you have a value of 0.5, so half, you get half the maximum amount of photons. And if you have 1.0, which means the full value, you get the full amount of photons for that channel. So you work with photons, and in the end you just say like, okay, we have this amount of photons for red, this amount of photons for green, this amount of photons, a photon is a unit of light, sort of. We have this amount of photons for blue, and we convert all of these values back into sRGB so that the display knows what to show it like to the end user. Our albedo map, so the coloring of the texture, was actually defined in sRGB color space. Almost every image manipulation program that you have out there is working in sRGB because it's always meant to design graphics for a display. And in the fragment shader, let me show you, I define two functions, linear to sRGB and sRGB to linear. So we can convert between these color spaces anyway. But what we used to do is we take the colors of the texture, we convert it to linear color space so we know the amount of photons we're working with for this material. It's all good. But what happened? We used to do this sRGB conversion in the texture converter too. sRGB to linear, linear back to sRGB. We're now packing albedo textures, normal maps and material maps in the same files. But what's the problem here? The normal maps, they are not an sRGB color space. I mean, we see them as sRGB colors here because it's being projected to the display, to the screen. But what they actually are mathematical values defining the vector, so the direction that light is bouncing off of these surfaces. And that's not sRGB color space, that's a linear color space. But what we were doing was taking these linear values, these vectors in linear color space or in linear mathematical space sort of, and we were incorrectly converting them to even more linear sort of. This is not sRGB. And then you get to the material map. This is also not sRGB. These are not colors meant for display, and these were not designed as colors to be displayed in any form or way. What I did is teach the texture converter to not convert any colors. So it will treat everything as already being linearized, so that fixes the downscaling and the scaling and the value calculations for normals. It fixes the calculations for the materials. The only thing that I now had to do was to convert the sRGB color information for the albedo textures, so this part. I now make these linear. So we don't have to do any sRGB conversion anymore. Every RGB value is now linearized, and that's why the wood now looks so much better, and that's why the nails aren't as visually apparent anymore. And that's why the roofs, the reflection is now better as well. And if we get up on the roof here, like there's no weird pixels going on, the interpolation that's being done while rendering or in the engine itself, you get these nice glossy highlights. So even on minimal detail level, now they still reflect correctly. And again, it also works for the material mapping itself. So that's why the nails now have this correct shape and this correct interpolation. So previously they were too big or the edges were too sharp and they were too metallic. But anyway, let's not get distracted anymore. We're going to draw our textures.